Welcome back to the Applied Impact Evaluation course. In this section, we're going to continue to work on tools for identification. And the particular method we're going to look at is called differences in differences. Let's introduce differences in differences in the context of an intervention. Consider an intervention designed to improve school performance. We'll measure school performance by percent correct on some test. We'll look at an intervention after school tutoring that's designed to prepare students in order to perform better on those tests. The chart gives us the data. The columns talk about the particular groups. With the program would be the treatment group, the first column. The second column, without the program, without the tutoring, is the control group. Then the rows give us the timing of the measurement. The last row, pre, is the test score prior to the tutoring, and post is the test score after the tutoring. If we go to the pre-row and we compare the score with the program to without the program, we see that kids who decided to get the tutoring, or families that decided to get tutoring for their children, they were scoring 60% on the test. Kids that didn't get the tutoring, they were scoring 78%. Well, what this suggests is that children who got the program were kids whose parents felt that they needed the extra help in order to do better. Those that didn't get the tutoring were probably from families where their parents felt they were doing well enough without the tutoring. So let's look at two particular differences. The first differences are the before and after, or the pre and post, for kids who got the tutoring. Post, 0.74, minus pre, 0.6, gives us an increase of 0.14. So the group that got the tutoring increased their performance on the test by 14 percentage points. The problem is we don't know if the increase in the score was due to just the tutoring program, or it might have been caused by other things that changed over time. The parents got a job, the kid decided not to work after school, they moved to a better house with better lighting. There are other things that could have changed over time. If we go to the right and look at the change over time without the program, we see that even without the tutoring, test scores increased by 3 percentage points. These are due to environmental factors that might have changed over time. If the change in environmental factors affected both the treatment group and the control group in the same way, then the change in the control group without the program is an unbiased estimate of how the treatment group would have changed over time if they had not gotten the tutoring. So what do we do then? We take the difference with the program, pre-post with the program, and subtract out the difference pre-post without the program to get 11%. The difference with the program picks up both the effect of the tutoring and the effect of factors that change over time, and the difference without the program measures the effect of factors that change over time on test scores. And so by differencing that out, we have just the impact of the tutoring program on test scores. And so we get a difference in difference of the pre-post difference with the program minus the pre-post difference without the program. Let's look at this in picture form. Here on the vertical axis we have test scores. On the horizontal axis we have time. So if we look at the group that gets the tutoring, prior to the tutoring their test score is represented by point B, or 60%. After the tutoring their test score rises to 74%, point A. Now we look at the control group. At baseline, prior to the treatment group getting the tutoring, test scores of the control group are represented at point D with a value of 78. At end line, the test scores rise to 0.81. Now let's look at the difference in differences. Essentially what we do is we take the difference between point A and point B and subtract out how much B would have risen without the tutoring, and we use the change in the control group to measure that, plus 3, and that gives us an impact of 0.11. Now, how do we know that this is a good method? When we're doing randomized designs, we checked baseline balance by seeing if the means of the control group were equal to the means of the treatment group prior to the intervention. That was the case where the counterfactual is what would have been the test score had we not had the tutoring. In this case, the treatment is the change in the test scores from tutoring, and the counterfactual is what would have been the change in the test scores without the tutoring. So we estimate the counterfactual by using the change in the control group. Now the analogy with baseline balance is to say prior to intervention, is the change in the control group the same as the change in the treatment group? If they are, then likely in the post period, if there had been no intervention, there would have been no difference in the change in the control group from the change in the treatment group. If the pre-intervention trends are different, like they are now in this picture, then maybe we would have forecast a different counterfactual, and in this case, we would have underestimated the counterfactual and overestimated the impact. Remember, difference in differences compare the pre-post change between the participating group and the non-participating group, the counterfactual for the trend or the change in the indicator. It assumes that in the program's absence, trends between the participant and the non-participant would be the same. To test this idea, we'd like to have 2 observations beforehand and 1 observation afterwards. We can use the 2 observations prior to intervention to test whether or not the trends in the treatment group were equal to the trends of the control group. So far, we've reviewed a set of alternative methods for impact evaluation. We've looked at experimental methods, randomized assignment and randomized promotion, and we've looked at quasi-experimental methods, regression discontinuity, and difference in differences. How do we choose among them? Which method should we use? Well, there are a number of key questions which help us answer that. One is the analysis prospective or retrospective? Second, what are the criteria for eligibility? Is there a particular focus? Are there geographic restrictions? Are there income restrictions? Can we implement the intervention immediately, or is it phased in over time? How much money do we have to meet potential demand for the intervention? Are there budgetary constraints or inability to implement? Do we have excess demand for the program? Selecting a method, what we want to do is we want to choose the best design in the operational context. The best design is one that has the most robust counterfactual plus the minimal operational risk. One question we want to ask, have we controlled for everything? Do we have internal validity? That is, do we have a good comparison group, one that provides an unbiased estimate of the counterfactual? Is the result valid for the relevant population? Do we have external validity? Does the method give us local or global impact? How would the results apply to other relevant populations? Now turning to the particular method, there are a set of conditions we have to consider. The first, we might think about our resources. Do we have excess demand for the program? In other words, there are more people who are eligible than we have enough ability or money to provide them. Second, there's no excess demand for the program, so we can provide the program to everybody who's interested. The focus of the program, or the targeting of the program. Now we have 2 particular criteria. One is there some continuous targeting or ranking measure or a running variable, and is there a cutoff? For example, If we have a pension program, we give it to the continuous targeting or ranking criteria would be age, and the cutoff is we give it to people over 65. Or there's no continuous targeting or ranking cutoff. Finally, timing. Here, because of various reasons, usually related to resources, the program needs to be phased in over time, or we can immediately implement it everywhere. Based on these criteria or these rules of operation, we can pinpoint the particular method that we want to use. If we're in a situation where we have excess demand for the program, i.e. limited resources, and there's some continuous targeting criteria with a cutoff, in both the phased over time and the immediate implementation, we can either use randomized assignment or regression discontinuity. If there's no continuous cutoff, well, we no longer can use regression discontinuity. We might be able to use random assignment, and in particular, in the phased implementation, what we would do is randomly assign who goes first and who goes later. We could use randomized promotion techniques, and indeed we could also use diff and diff with matching, but difference and difference with matching is less robust than either of the randomized methods. With respect to the situations where we don't have excess demand, i.e. we're fully resourced and we can we'll eventually have enough money and ability to provide the program to everybody. In the phased implementation case, well, we can again do phased randomized assignment, that is randomizing who goes first, second, third, or a regression discontinuity design. If we're in the case of immediate implementation, we're then restricted to the RDD. We look at the last issue related to fully resourced, no continuous targeting or ranking cutoff. If we're forced to phase in the program over time, then we can use phased random assignment, phased randomized promotion, and diff and matching. And finally, if we are fully resourced with no continuous ranking or targeting and immediate implementation, then we're either doing randomized promotion or diff in diff with matching. Remember, the evaluator's objective is to estimate the causal impact of a program on the result of interest. To measure the impact, we need to estimate the counterfactual. What would have happened if the program did not exist? This is why we use control groups. We use control groups to get a better estimate of the counterfactual. Our toolbox to evaluate impact evaluation offered 4 methods to select a particular control group. We want to choose the best viable method based on the program's operational context. Thank you very much.